This is Q4b. In this example, again, we are sending a cosine, 2 cosine pi over 20n plus a phase shift pi over 3 into an LTI system. And in this case, different to the previous example, the LTI system h of n is an infinite impulse response described by this equation here. Well, we know from the previous equation, previous question, that once we have an infinite impulse response, we have to deal with it analytically. And we saw that because this is a geometric sequence, then the DTFT becomes a geometric series, and this is the DTFT of this infinite sequence. Right, the interesting thing here is that we are only interested in omega at pi over 20. What is this pi over 20 again? It is exactly this pi over 20 here, the frequency of the cosine that we are sending in. So we are only interested in the frequency response at this frequency because this is the only input that we are thinking about. We would get h of omega, which is called the frequency response. And when we say omega equals to pi over 20, we are saying the frequency response at this frequency. Right, once we calculated it, we will get a complex number, which is here. And then we convert it into magnitude and phase. Alright, so the magnitude gain is 1.9. Basically, you'll blow up the input signal by 1.9, almost 2 times. And you introduce the phase delay of minus 0.1533 radian. Okay, so let's see. That's what we do. We'll substitute this equation 1 over 1 minus 0.5 e minus j omega to get h of omega. So this is exactly it. And then we'll get the magnitude and the phase. And then the steady state is again, of course, the magnitude gain. So this is h of omega multiplied by the original cosine. And then this is the pi over 20 and the frequency of interest, omega. And the phase shift that we are interested in, the original one is plus pi over 3. And then plus angle of h of omega. Okay, that's it. Once we have typed out this equation, we would ask him to plot yn steady state. So this is yn steady state. Again, the green guy is the input, which is a cosine of amplitude 2. And then we would have the output. So output rate is the steady state. So this is the steady state. The steady state is also a cosine. And then it almost reaches 4 because it's 1.9 times 2 for the magnitude. There's a little bit of phase shift. Okay, minus 0.23, I think. Well, minus 0.1533. So this is a phase shift. And then we get the output. Now, again, remember, why is this the steady state? It looks like the cosine is very nice and smooth even at the beginning. Right? So see, it's very nice at the beginning. It follows the curve of the cosine exactly. It is a steady state response, assuming that the green, the input, actually stretches back in time. So we call it the steady state. Well, the method 234 assumes that the past input x is 0. That's why you have this transient, because we are feeding 0 into the system. And then that's why this takes a few samples, 1, 2, 3, 4, 5, 6, about 6 samples before it merges to the steady state. Okay, so method 234 we'll now explore. Okay, what's method 234? Well, again, method 232 is the convolution. And again, because if this is impulse response is infinite, we can't do this. So what do? Well, in this example, we choose only 15 times. Okay, we are only using the first 15 samples of h, n equals to 0 to 14. Of course, again, the index starts from 1 for MATLAB. So we are using the first 15 and we are doing the sum, like what we have done in the question 4a. and then this is the blue guy. So the blue guy, again at steady state, the red and the blue looks the same except in the front. Okay, so what else? What about using convolution? Actually, this we're going to tell you that convolution operation in MATLAB is exactly the same as what we have implemented in the for loop. And finally, filter is what the MATLAB does when you have B and A coefficients. Okay, so B and A's. B is what? In B and A, so now B is no more the impulse response you see. So you realize that later on in Z transform, you will see the B and A coefficients in play. They are the difference equation realization. Please ignore this until the Z transform and come back and revisit this. And this is in the red, and you will see that the response of the red X is the same as the method 2 and 3. And okay, method 2, 3, 4 all produce this. Method 1 produce these red crosses, which is the steady state, and green is the input. So with that, we have answered question 4b again using the 4 methods. Thank you.